So let me do this. I've got copies of the hypothesis test worksheet. Printed out upstairs. What I kind of want to do is get us to a point where you guys can start to work on a problem. I can run up and grab copies of those for people that need it. We're going to do an example of a hypothesis test together. And then on the other side of the paper is what I want you guys to do. So we're going to do the example together. You can start working on the one by the back. I'll run upstairs and grab that. Okay. So I've got 4 examples we're going to do today. We'll talk about type 1 and type 2 errors. And then whatever time it is, we're gonna leave now. So let's do this here. As your bonus question. I never put extra credit sections as a normal question.
It's gonna make the step on 10 extra credit.
Huh? The test is next, is a week from today. Which is Monday, yeah. Today's Monday. Don't do that to me. Say again? The test is on Monday.
Because I thought it was Wednesday.
It was originally Wednesday.
Oh, okay, we did that.
And then I have moved it because I got that power.
He was sick.
You keep freezing your power for good.
Yes.
Yeah, you could have used this power for evil.
Good, because I have another test on Wednesday. I have a microbiology test on Wednesday.
Lawful neutral. I don't know what, yeah. Oh, sorry. So I got 1 left for me. Good. So, okay, if you weren't here, holy shit, you want to watch that video, because I'm not necessarily going to say everything I said already. We did a lot, let's just say. Yes, it was a lot. So you hear that? Good, that means it's growing. Lots of pain, lots of gain. Okay, I just got my crappy pen, that's fine. No problem, okay. Alright guys, so. Has anyone started the chapter 9 homework?
Yes.
Yes? So just to lay a few things out, because I always forget to say a couple things. Section 9.5 is the first section that has a full hypothesis test. Every section sort of focuses on a different part of it. Does this make sense so far? There are a couple little details like the type 1, type 2 error that we're going to talk about after we do a few examples. So we'll talk about what those are. And the homework references, I think I said this, a worksheet in the back of the book. Oh, screw that worksheet. We're doing these steps. So when you do the hypothesis test problems in section 9.5, you do these steps. Everybody with me? Okay, all right.
What's up with the poetry questions?
Do you wish I would have assigned them, or?
I don't know, they like.
I know. I don't know.
Don't give him
I-
ideas. Don't.
No. I don't want to grade any of that. So, again, that's good. I can assign the problems I want to look at. All right. So read through this problem. The one about the Subaru Forester. Anybody have a Subaru Forester?
I don't know.
You have an Outback?
Yeah.
I was thinking about getting a Subaru Outback, a Forester, but I ended up getting a CRV, and I love Honda CRVs.
I don't know that.
It's actually, I mean, you can get a CRV with 4x4, not all-wheel drive, but there's less risk of oil starvation
True.
or head gasket.
Yeah, that's one big thing about Honda is
Spark plugs are easier to do because
I think there's like a portal to another dimension that the oil just goes into.
on Subarus, yes.
It's insane.
And because it's a boxer engine, your spark plugs are facing your fender well, so you're never going to be able to get to them. So.
But everything else is great.
Oh, they're good cars.
So it's easy. But I'm with you. Those suck. So read through it. So whenever you're doing a hypothesis test, what kicks everything off is what is the claim. So before you try to do HOHA, you can't do it until you know what the claim is, because the claim could go in either spot. Can somebody remind me The statement that ends up next to the ho has gotta have a what in it? Equal sign. I love it. By the way, if you weren't here, H naught is how you say this. H naught. It's also called the null hypothesis. It's also sometimes affectionately referred to as the ho. And then you got the ha's, the alternate hypothesis. Okay. What is the claim that somebody's making here?
Let's see if their assembly time is the same as the overall.
Yeah, the claim is it's still we're trying to test the claim that it's still the same. So they made some changes, and we're trying to see if the assembly time is still the same. So how do you write that claim in Mathish? The same as what?
Equals.
27.2.
Same as what?
Equals.
No, same as what?
The mean assembly time.
The 27.2, correct? What number would never show up here? Which number up in here?
26.7.
Yeah, that's the sample mean. This is a claim before I've taken a sample, I have a claim. Is everybody with me?
Yeah.
This is artificial because they just spit everything out of me, but in real life, we'd make a claim and then we'd go take a sample and do stuff, right? So the claim is the mean at this other assembly plant is the same as the overall average. So we're trying to find evidence against that. We're trying to find evidence against the null, and I kind of gave it away. This is very obvious. Am I going to put that statement next to the null or next to the ha?
No.
Give me a second. I'm going to try this one more time. Did I get it to work before? I did, didn't I? Oh, wait. No. Is that enough light, or do you guys?
No, turn it on. I'm gonna fall asleep.
Yeah, just leave it on.
Yeah, it is.
All right, wait a minute.
A warm, dark room, yeah.
Oh, there. Okay,
Yeah.
that's what I want. Sorry. Okay. It's just this. Now there's less glare. Yes. Okay. Sorry. It doesn't take much. I'm very excited. So where's it go? I'm sorry. Where's it go?
No.
And then no. Why?
Because it's equal.
It's got a freaking equal sign. And then so is everybody with me? This is how you do every single freaking hypothesis test problem. Somebody somewhere in the problem is making a claim. Normally you're going to see stuff like, we think it's increased, we think it's gotten lower, we think there's more of it, we think it's at most this, we think it's at least, those are all directional words, correct? So that would be a one-tailed test, because there's a certain direction that I want my sample to show up in. This claim is, it's the same as. So what's the opposite of that? Not equal to, so how many tailed test is this?
2, up or down.
2. To be not equal to, you can be bigger or smaller. Cha-cha! So two-tailed test. How we doing? We're doing all right, Jeff. Okay. Now, do I use Z-scores? Bless you.
Z-scores.
T-scores or nothing?
Z-scores.
Can I use Z-scores?
Yeah.
Why?
Because we know that the sample is bigger than 30, so. it's-
Good, the sample size was 73, which is bigger than 30, and?
We know the population standard deviation.
Good. So if you say we can use Z-scores because we know the standard deviation, no, that doesn't make any sense. There's 2 types of standard deviation, population, sample. If I only knew the sample standard deviation and n was bigger than 30, what do I have to use? If I only know the sample standard deviation
We have to use
Oh,
T.
T.
and n is greater than 30, I have to use T-scores. That's why they were invented, for when I don't know the actual population standard deviation, because they make everything bigger, cover my ass for the thing I don't know. Yes?
I'm sorry, just to go over again, why is it 210?
Oh, are you cool with the claim being what it is?
That has to equal 27.2.
The mu is 27.2, is that cool? All right, and so that goes here. The other one's going to be the opposite of that.
So it could go in either direction.
Not equal to, how can you be not equal to something? You could be bigger or smaller.
Okay.
Yeah.
Just having.
So if there's a directional word, like increased, decreased, gotten bigger, at most, at least, that's going to be a one-tailed test.
Okay.
Yeah. Okay. This one hides sometimes because people don't realize the word is. You know, we had a big problem with the word is in the late 90s. But the word is huge here. That means equal to. Yeah. but it's really easy to miss. What about the rejection region? Does everybody still have their T-score chart? Ooh, I have some. Why am I using the T-score chart? Didn't we just say we're gonna use Z-scores?
Are we gonna use the bottom of it?
Yeah! Sorry. I gotta calm down.
Do we need the T-score chart to realize that if alpha equals 0.02, then that means on a two-tail test, each tail will be 0.01, therefore we're looking for
Technically,
98%.
you don't need the T-score chart. It just makes things easier.
Subtract that from 1 and be
Yeah.
like, okay.
Yeah, it just makes things easier. So it's a two-tailed test. So if I wanted to look this up on the Z-score chart, I would look up 0.01 on the Z-score chart.
Mm.
Or I just do this, which makes it easier because this is how many tails. And alpha was 0.02, right? Is that what I just said? Yes. So two tails, 0.02. Where do I stop?
All the way
Two
down.
point
I don't stop. Yes.
one.
So 2326. Okay, what's that number mean? What's that number mean?
Sure, rejected.
That is the Z-score beyond which
Sure, rejected.
things are unusual. Or not
Isn't it
unusual.
if it's higher than 2.326?
Good. Yes, yes.
Four star?
So it sets up the benchmark,
Yeah.
right? It says this is where evidence starts. If you get it past this, more than 2.326, he found evidence against the null. It's so far away from where he thought it should be, this guy's probably wrong. So I can reject him. If I don't make it past 2.326, you ended up close enough to that where he thought it should be, not good evidence that he's wrong. Okay, I don't know if you guys are with me. Because again, in this picture, the null thinks it should be in here. So if I find a sample out here somewhere, then that's evidence against the null, because I didn't show up where he thought I would. Maybe. So in this case, how many tail tests do we have again?
Two.
So I have 2.326 and I have
Negative.
negative 2.326. So how do I say this in words? If Z star shows up where? Either, how do I say in here? If Z star is
Greater than 2.3.
Greater than 2.326 or
Lower than.
lower than negative 2.326.
Reject-
Somebody else tell me, oh,
Oh,
good.
sorry.
Somebody else tell me what happens if you get a Z star that does one of these things? What happens if I get in here?
Then
You
we-
reject the claim.
Reject the null, which in this case is the claim, but in general, if I get in here, I can reject the null, support the high. So again, I know we're still relatively new to this. The null always has what?
Equal.
The null always has some kind of equal sign. Exactly. So he's the guy who thinks it should be in here somewhere. Because he's the guy that says part of what he says is it's equal to this. It could be equal to this. This means it should show up in here somewhere. So if I show up far enough away from there, that is evidence against what he said, because if what he said is right, the sample should show up in here. Is it proof that he's wrong?
If it's outside?
Yeah.
Yes.
Never! It's never proof. Never proof. All we got in science is frickin' evidence. That's all we got. We never got proof. Damn it. Sorry. Go ahead.
Do you want us to write if Z star is greater than blah blah blah? As part
Yes.
of the
So I
claim?
always say define. So when I say define the rejection region, that means draw the picture, and then I say put in the words also.
What about reject that, support that?
Huh?
What about the reject and support that too?
That is the completion of this statement.
Oh.
If you just say if Z star that and that, I'll be like, then what? Yeah. Okay. So I desperately, at the heart of this is almost too simple to believe. One person, one statement, thinks it should be in here. So if I get outside of there, that is evidence that that statement is wrong. That's why I can reject this guy. If I do get out there. If I don't get out there, if I'm in here, that's not enough evidence that they're wrong. So then I fail to reject what he's saying. Is everybody semi? I know there's 5 steps, and I know they each got their own shit. But at the heart of it, a hypothesis test is just, where does evidence start? What's far enough away from the middle that you've accounted for samples can be different. So I'm so far away that that's not just a different sample, that's freaking evidence that it's different. Yes?
And that interval was our confidence interval that we were using for 8 point, or what's the? where's that coming from? It's just-
No. So here's the thing, okay. Confidence intervals are built around sample means or sample proportions. That's why to test a claim, they suck. Just to get a feel for what the data is, though, they're great. They're not meant for claims testing. If I create a confidence interval and I'm like, whoa, that's way far away from what, then I'll come do a hypothesis test. Hypothesis tests are built around actual means. And we'll do one today with actual percentages of populations. They're assumptions we make, but they are a valid proof structure, like a proof by contradiction. Assuming the mean is this. If we get way over there, that means, holy shit, then that must be wrong then. Yeah.
So then what's the significance of alpha being 0.02 and not anything else? So
I like the word you use, significant, because if alpha was bigger, if alpha was 0.05, you guys with me? This would have been 1.96. Then it would have been less significant if I passed the test. So if I have to get in here to show evidence against the null, that's okay. If I get out there, okay. If I just have to get out this far, isn't that an easier test to pass? So then it would be less significant evidence. So that's why we call that the level of significance. The smaller that number is, and I pass that test, the more significant the evidence is.
So it's harder to get there.
Harder to get there because it's freaking further away. Yeah.
better evidence.
Better evidence. So for example, an example I love to give, and this is sitting on something, a quiz or whatever, trying to prove to the fire department that your insurance go down. We talked about that before. They're going to set up alpha to be 0.005 because they want your freaking money. Yes? So they want to make it really hard for you to show evidence that your insurance should go down. Since they can set up the test, then that's what they do. All right? Okay, maybe. Okay. So, what the hell are we talking about? So the claim gets us started. What can we use to talk about it? Where does evidence start? Or another way to say this is how far away does my sample need to get? And then the next step is just how far away did my sample get? Right? So can somebody tell me what did we find from the sample in this? What was X bar?
26.7.
26.7. Sigma we know is 1.77?
Yeah, 1.77.
So what's sigma X bar?
0.207.
Yeah, 1.77 divided by the square root of
And
73. I love it. So step D, this step, it's always going to be the same. Get your stuff from the sample, make a z-score out of it, call it z-star just to make Jeff happy.
Why do we run that? I forget why we run the conversion of doing standard deviation divided by. Isn't that to convert it into our sample?
Nope,
standard
never.
deviation?
Nope, definitely not. No. This is how spread out individual cars are.
Oh.
And I need to know how spread out groups of 73 are. So when I do this, it's all I'm doing. That's why if this is S, I still have to do it. Because S is still a spread of individuals. I still have to do S divided by square root of n. You guys semi with me? I love, see your eyes like this, like, come
would
on,
that be S?
come on, end this semester. Huh?
Would that be SX bar?
SX bar, yes.
Yeah.
Somewhere there's an animal bar joke, but I think you tried to make it.
Wait, this isn't SX bar, it's sigma.
This is, if it was S, it would be SX bar. But this is sigma, so it's sigma X bar.
Oh, right, because we might not know the population standard deviation if you only have a sample.
And then we're using T-scores, yeah. So help me out, I think Nick already said this, but what are you guys getting for this?
207.
207.
207?
There was 1, 207.
Okay. Now take a minute, nobody say anything, figure out what Z-star is. Z-star. So it's always our data minus the supposed middle divided by the correct spread. That's what Z always is. So what was our data? What did we get from our sample?
26.7.
26.7. The supposed middle, 27.2. Divided by the spread, 207. Times 5. That would be, if I could just read my own writing, that would be easy. 2.5.
Do you want two decimal places?
2 point something.
Negative 2.42.
Negative 2.42.
I'm sorry, can you write out literally the formula of what that translates to? It's to like the music.
So here's the thing, okay.
Oh, it's
Z-
X
Z-
bar
Z-score formula.
minus.
You ready? Yeah,
the
so here's the
sample.
Z-score formula, the very first Z-score formula we ever learned, yeah?
Mhm.
This is the same, it's always our data, but our data now is the sample mean, minus the supposed middle divided by the spread. That looks more complicated than this, but these are the same damn formula. Our data minus the middle divided by the spread. So my claim is the Z-score formula never changes. Today, you'll probably think I'm insane. But we'll see.
Well, it's every day.
I already think that, John. It's everything. I appreciate the candor. Alright. Now, real quick, did we beat the test? Did we succeed? So let me ask you this question. Okay, so what level was the test? What level of significance was it? 102. Let me ask you this question. Let me see if this question makes sense. I'm curious, couldn't the test have been a little bit harder and we would have still passed it? Do you see what I mean? I really want everybody with me. It was 0.02. It set up this boundary, yes? And we beat that boundary by a decent little bit, yeah? You guys with me? So couldn't, if they made the test just a little bit harder, we could have still passed it, yes? You guys see that? So I'm curious now, and again, this isn't just me, by the way. This is going to be an actual part. This is going to be a question I ask you. This is me making shit up on the spot. This is a real thing. What level of test would we have passed?
Probably 99. But
Let's get the exact number. You ready?
0.01.
You ready? So what I want us to do, if I could just move this down so it's right on negative 242. I really want you guys with me. If I just, here's negative 242, yes? So right there, I want you to understand, right there, the problem is done basically. We just have to write the conclusion. We reject the null, support the ha, yes? Yeah, here, all these stuff, okay. We got the answer. What I'm about to do seems extraneous, but to be honest, it is everything. What I'm about to do right now is everything. So what have we been doing, Jeff? If I were, I desperately want this to make sense. If I were to push this until it was right on 242, I would still pass. Do you guys agree? If I were to push this boundary until it was right there, which means I'm going to do what to alpha? Aren't I going to make it smaller? How do I tell exactly what value that would be? Well, if I push it right to this, wouldn't it just be the area in the tail of this? Yeah, it's old news. What's the area in the tail of negative 242? Z-score chart. Old news. Yeah. Let's try to make the system cool down here. Pretend like it listens to me. So I'm sorry, what? Negative 242.
0.0078.
Yeah. 0.0078. everybody with me? Now, that's not really what alpha would have been, though. Let's see if you guys are really cool with this.
Let alpha cut in half.
Beautiful. So this area would be 0.0078. Notice that that is the area in the tail that our Z star made. That's all it is. Does everybody agree that's not what alpha would be? That's alpha cut in half, correct? So if I double that, what do I get?
Alpha.
Point
Cool?
No.
Are you guys with me?
Why are we doubling it?
Because how much area is in just this tail right here, for example? How much area is just in that tail?
Is that from 2.3?
How much area is right in this? Yeah, exactly. How much area is right there? You know it.
0.02.
No,
It's 0.01.
0.01. Because where's the other one?
The other one.
Over there. Yeah, so when I have a two-tailed test, it gets split between the tails. So alpha is always the total area in the tail or tails. So if I want to figure out what alpha could have been, and I still would have passed, once I find this number, I have to double it because there's a whole other side. So we passed officially a 0.02 level of significance, yes? We knew we could have passed a little bit harder of a test. Because didn't we, this was the benchmark, and we made it there. We're like, oh, the test could have been a little harder. Right, where the teacher says, okay, no. But you guys with me? They could have made the test a little bit harder. I could have pushed this out a little further, and we would have still passed. How much would alpha need to change? It would have to decrease a little bit. Well, it would have to become 0.0156 instead of 0.02, just a little bit lower, yes? I am very excited, by the way, because I've never taught it this way, and I don't know why, because that makes nothing but sense. Now, you guys are like, that's good for you, man. I don't know what the shit just happened. So real quick, alpha's 0.02, alpha's 0.02. The reason there is a 1 and a 2 tail option is because a 2 tail option cuts it in half, yes? So if I put all of the area in one tail, that would have been here. But this is a 2 tail test. Sorry, 1 tail. Don't look at the monitor, Jeff. Don't even have an O2 option up here, but 2 tail test, O2. That means there's 1% in each tail, yes? Okay. We found this was 0.0078. So if I double it, that is the alpha that we could have passed. That is called, believe it or not, the p-value. So when I ask for the p-value, it's just the area in the tail of your z-star. If it's a 2 tail test, you got to double it. Yes?
And when you refer to passing, it means
Getting in there.
with
Getting far enough away.
Rejecting.
Yes, rejecting. Yes.
Okay.
Yes.
Rejecting that.
Every hypothesis test doesn't give a shit what you think or hope. It's trying to reject the null. It's what it's trying to do. So when do I succeed? When I get far enough away and I show that it's wrong. When do I fail? When I don't get far enough away. Yes?
So, if you do ask for the p-value, we just literally take the answer that we got from.
Look it up in the chart. If it's a 1-tail test, that's the answer.
But we use what
If it's a
we found
2-tail test, we
from
double.
D. And then we just take.
Yeah, whatever our
take it
z-star
back.
is the area in the tail of it.
Okay.
If it's a 2-tail test, you just double it.
Okay. Oh, thank God. That sounds easy.
I know, that's all it is. Yes?
My other question was negative 2.42. Why didn't we round further? How far do we want to go in terms of decimals?
In general, this is the 2 places just because our z-score chart only goes to 2 places, right? So to look up the p-value, I have to round it to 2 places. Now, if it was really close to this, then I would probably round it less. So then I can get a more accurate. You with me? If z-star came up to be negative 2.326, which is exactly what that is, I might round less to see which side it fell on. Does that make sense?
No.
If I round and I get negative 2.326,
Would it just round to 2.33? Negative 2.33?
so what if it was negative 2.3259? I would have failed, yes? Everybody with me? And if it was negative 2.3261, I would have succeeded. Yes? So that's the one time you could round your z-score less. In case you're like right on the damn boundary. You can see what side you're supposed to be on, yeah.
I just wanted to double check for p-values. So we just take our z-star, look up the area the z-star represents, and for a one-tail test, that's where we stop. That is.
Yep, that's it.
And
And
then
the
if we
two-tail
just
test,
stop-
you done it. So we'll do more examples, obviously. What was our claim? Which one, the hoe or the ha?
Oh,
Which call? Oh yeah, the hoe. So which language am I gonna use?
Reject.
reject them.
This language. So you always wanna have your answer reference the claim. There's never any frickin' guessing. It isn't. You go, oh, my claim was the null. I'm gonna use the language associated with the null. So we have found sufficient evidence to what, do what?
That the assembly.
No.
To
We found
reject the
sufficient
null.
evidence to
To
reject the claim that
assembly time of the Subaru Forester
assembly time
is not the same as the mean assembly time.
of Subaru Forester is the same as general. Sure, that's an approximation in English. And those are approximations of letters, so it all works out. We found sufficient evidence to reject the claim that the assembly time of of Subaru Forester, in my head I was saying San Francisco earlier, whatever that, of Subaru Foresters is the same as general assembly time, right? You could just plagiarize. You could just say, we found sufficient evidence to reject the claim that the assembly time at this plant is still the same as the overall average. You can just use exactly the same language because we are reporting on somebody's claim, so we want to repeat their claim to them. I love you guys. There's 5 steps. That always really troubles people, but each step is not that bad.
You have an awful name.
I do?
Like, what does that even say? We have found stuff?
Yep, we have found stuff. We have found sufficient evidence
So,
to reject the claim that the assembly time of Subaru Foresters is the same as general.
incorrect.
All right, let's do another one. So the only way to learn this stuff is to do more and more and more. So I want you guys to get as far as you can on number 2. Feel free to work together. I'm gonna run up and grab the other stuff. Debt has increased. I love it. So always find the claim in English. Good start. Now translate it to Mathish.
It's gonna be a ha, right? Because it's a direction.
Well, I don't know. Let's find out. So the claim is the mu
Mu is greater than.
Greater than?
286.
2806. I love it. And you can identify the other mean came from the sample, so it's never going to show up in the claim because I make the claim before I take a sample. Okay, so just double check and make sure you didn't put a sample mean in there. Now, like Martin was saying, where am I going to put that? In the hop, because it does not have an equal sign of any kind. So what's the hoe going to be? Jeff, what are you doing, buddy?
Less than or equal
Less than or equal to.
That's what I was saying it while I was writing, so that's awesome. So that's how it works. You find the claim, you put it where it belongs. Does it have an equal sign? Next to the null. Does it not? Next to the ha. And whatever's left blank is the opposite. Yes?
So you have a less than or equal to
Yes.
for your hoe. Will that make it a two-tail test?
Alright, 2
We'll
things.
be looking at
Two
both
things.
of those?
2 things. Rejection region always comes from the ha. That's how we've set it up. That's why we always make the ho the one with the equal sign, because I can never show evidence for equality from a sample. I can only show evidence against being equal to something. So the way we set this up, the ha will always set up the rejection region. Even if that was true, there is still only one direction I'm interested in. You would just have your tail in the wrong direction if you look at the ho, though.
Yeah.
So looking at the ha, does everybody agree this would be a one-tailed test?
Yeah.
I could have went insane, you never know. So right now I didn't. which side would that tail be on?
We're looking for an increase, so it's gonna be on the right.
Looking for an increase,
That's right.
so it's gonna be up here. The important thing here is it's a one-tail test. So this is awesome. The Haas sets up the rejection region. When it's an inequality, it's a freaking arrow. How's this going? You guys all right? Inequality symbols are always arrows. They're trying what they can to help us out.
Oh, I was taught they were alligator mouths.
Sure, alligator mouth. Okay. Did you guys get much further? Alright, do part B. We'll do this one thing at a time. Try to do part B. You're looking for two things in part B, yes? Is it normal? So it could say it's normal, so be careful. The sample size is less than 30, it better say it's normal. So it's got to do one or the other. And then the second thing would be, which standard deviation do I know?
Yes.
Okay. So is it normal?
Yeah,
Normal enough?
yeah,
Why?
because
And
N
the
is
sample
greater
51.
than 30.
51 is greater than 30.
So chicken, lettuce, tomato says good, or central link there. And then secondly, which standard deviation do we know?
S.
Yeah, so sigma unknown. Only S. And again, can you guys see why that's true?
What's the CLT, OLT?
Central limit theorem, I'm sorry, you don't have to put that, it's just, that's the name of the thing, central limit theorem. Where did that standard deviation come from?
From the same.
From the sample. From a sample, blah, 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 blah. So you have to read context. Don't just go, hey, I got a standard deviation, that's z-squared. No. The whole idea is, which standard deviation? You have to know one or the other. If you didn't know any standard deviation, you couldn't do shit.
I mean, I look at the text and I try to find if they give us a population
Yes.
standard deviation, and if they don't, just
If you can't tell, it's a sample. Because if it was a population standard deviation, it would be really stupid clear. Yeah? It would say, population standard deviation. Or it would say the standard deviation for all is this. You guys kind of with me? This one says, from a sample, we got these things. Okay, that's us. So therefore, we have to use t-scores. Sorry, Nick, you've been sitting there waiting. You're like, come on. You guys with me? So that step always needs two things. Show me why it's normal. Which standard deviation do you know? Then you can pick which one you gotta use.
So if it's not normal,
Then the sample size has gotta be big enough, and the sample size is too small, it better say it's normal. And if both of those things are not true, you officially can't do it.
So it's
It
just.
would be a stats 2 problem, and we're not in stats 2. Yeah. Even then, I'd need the data, but no. So now I know I gotta use t-scores. So here's what I do for myself. It's a one-tailed test, yes? What's alpha?
0.01.
101, 11. And it's t-scores. So therefore, what do I need before I can look up the t-score?
Degrees
Degrees
of freedom.
of freedom. What's my degrees of freedom?
50.
50. So don't say anything. Take a moment. See if you can find that t-score. Don't say anything. I mean, you can talk, but just don't say the answer. So alpha 0.01, one-tail test. That kicks so much ass. This is built for hypothesis tests. I don't go all the way down, I'm gonna stop at
50.
50, and so I get 2.403. Is that all right? You guys good? Okay. Yep. 2.403, so if T star is greater than 2.403, what can we do?
Would it just be reject
Reject
the,
the hoe,
and then support the.
support the hoe. I like it.
And then because the claim was the HOB, that's what we referred to in the conclusion, right?
Yes, looking ahead, but you never worry, the claim gets us started and the claim gets us ended, right? In the middle, I don't give a shit. So at the end, I look back, which was my claim? It's gonna help me figure out how to state it, yeah.
I struggle with the conclusion statement, so it's always gonna start with a rejection because,
No.
No?
The conclusion, the actual conclusion? Or you mean just this little mini
I
thing?
guess maybe that part of it.
This will always be, when do I reject, because we're defining the rejection region.
Right.
Yeah.
And for the conclusion, that may differ, but,
Yes.
we're always.
If I get into here, it always means these. If I don't get into there, that means I fail to reject the null. Fail to.
Right,
support
because
the null.
if we find the opposite, it doesn't mean we've confirmed a new claim.
Beautiful. Just like saying you're not guilty instead of innocent. Okay.
Thank you.
Now, part D. Here's the thing. All right, summarize everything we know. What's X bar?
31.634.34.
Okay. And I remember my grad school days. I like to say I lived a very plastic life because, anyway, it's just the way it went. So it took me a while to pay off my student loans and my credit card. It was
How's
fantastic.
that a classy life?
Huh?
How's that classy?
Plastic.
Plastic?
Plastic life, because plastic card. It's just for me. Don't worry about it. What else do we know from the sample?
S,
S was,
1106.25.
so what's S X bar?
154.
Divided by square root of
51.
51.
Times by 4.906.
You guys all with me? I want you guys to be with me, yes. It's okay, go ahead. Take me back.
If we had the standard deviation of the population.
No, okay. Dividing by the square root of n makes it a spread for groups. S and sigma are both spreads of individuals. So whichever one I've got, I've still got to make it into a spread for groups. Does it make sense? That's why no matter what the hell I got, S or sigma, I still have to divide by square root of n because we took a group of 51. I want to know how is every group of 51 spread out. S doesn't tell me that. S tells me how spread out the individuals in the sample were. Is that all right? You sure? Okay, all right. So no matter what, whichever standard deviation you got, this step, you're gonna divide by square root of n when you're doing means. What do you get for this, sorry?
154.906.
154.906?
906. I got 906.
06?
Yep.
Okay. I'm crowdsourcing this. Sounds about right to me, yeah.
Are we rounding this since it's money?
We're rounding it because of standard deviation, so we'll round it to how many places?
3.
At least 3. Yeah. Is that right? Standard deviation, take it at least 3 places. Okay. Now here's the thing. Is anybody concerned that we don't know the t-score formula?
It's the same thing.
Same thing, yeah. It's still going to be our data minus the supposed middle
Over the,
divided by the appropriate spread.
that's X bar.
So z-scored, t-scored, never different. Our data minus the mean divided by the spread. It never is different. Let's see, what's that going to be, Jeff?
7 divided by 3.
It's like 2.3 something.
2.612.
2.6, okay, that's good enough. 2.612? Okay. Now, real quick, let me see. I haven't said anything about this yet, but I need you to understand. The z-score form, the z-score chart is insanely detailed, yes? Here's what you don't really understand right now, and there's no reason you should. The t-score chart, if I wanted to make it as detailed, every degree of freedom would have to have a chart this big if I had as much detail.
Why, to represent all the possible decimal places?
Yes. So therefore, I am never going to ask you a p-value question for a t-score. So if you don't understand what I just said, it's okay. I'm just never gonna ask you a p-value for a t-square.
Wait, why is it 2.61?
It's 2.6.
What is it?
2.26.
T-squared.
2.26?
Yeah.
Ah, it's better, because I said 2.3, right?
Freaked me out, I'm like,
I feel better. Okay. I was really worried about my mathing. I wasn't mathing.
can I put my test correction out here?
Sure. So what you guys got, 2.26? Why didn't you say something? Make me feel like
We were talking.
I understand. Did we make it?
Wait, what'd you say what'd you say before?
About,
Never mind, I'll just be watching.
yeah, that's a great thing about that. 226, where, did we make it?
Yeah.
No, we're down here. We got pretty far away from the mean, but not far enough.
6.
So did we reject it?
Not found sufficient evidence.
So we fail
Failed.
to reject the null, fail to support the ha. Now, coming back to what somebody said earlier. Right, all this stuff I can just write down no matter what. If I didn't make it in, these two statements are true. Then I say, okay, which one is going to help me write the freaking conclusion for this weird-ass stats teacher? Which one was the claim? The ha. I like it. So then I'm going to use this language. Fail. We have not found sufficient evidence to support the claim that plagiarize. Now be very careful. I'm not saying you should plagiarize in general, right? Don't be doing that chat GPT. Can you please write a 500-word essay on the origins of the American blah, 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 you know. Don't do that, kids. Right? ChatGPT is stupid sometimes.
It's a bad catchphrase. believe
You guys with me? You can ask ChatGPT to do stats problems. It'll do them. It'll make mistakes sometimes. Go ChatGPT. Because it's learning from humans. So guess what? It's freaking racist sometimes. It's freaking biased. It's freaking getting stuff wrong. Why is it doing all that shit? Because it's learning from us. And what are we all about? We suck. In so many ways. Yes,
You
sorry.
know stats really well, Professor. So I saw a report that said the new prevalence of AI has expanded so quickly that AI is now sampling big data from the internet from other AI.
Yes.
And is making progressive
Feedback loop. Yes. So it's propagating the errors of its own self and its clones.
It's like
Yes.
round-off error, it just gets worse
Yeah,
and worse.
yeah.
That's hilarious.
You guys, real quick, you guys know what ChatGPT is? If you don't, look it up because it's kind of cool. I like to do stuff like write a 6-word horror story in the style of Mark Twain. I like to say write a 200-word story in the style of Mark Twain about a pineapple, right? And it'll frickin' do it. It's stupid cool. I'm sorry.
Someone had one.
I also ask you to do math stuff, but
They
you know.
would write a song the opposite of the Pledge of Allegiance, and I did it. It was like really pessimistic about it.
I like it. You do all kinds of shit. Sorry. Okay. I'm sorry.
So the conclusion has
Coming
to be
back.
longer and fancier.
Did I lose anybody anywhere? The minute something I do doesn't make sense, you need to say something, right? See something that doesn't make sense, say something.
So, I have a question.
Yes.
In the conclusion, always go back to the claim and see whether you failed.
Yeah.
Blah, blah, blah.
You're gonna always write things here. Then you're gonna say, okay, what was the claim? The claim was the ha in this case. So I'm gonna use this language. So fail translates into we have not, yes. We have not found. And I'm gonna try to write in English, okay? Sufficient evidence instead of Jeffish. 2. That didn't quite work. The word 2 represented by a single letter, okay? 2. Support the claim that
That has increased.
plagiarize. Credit card debt has increased. Yeah, that's plenty good. Credit card debt has increased.
So we don't need to get specific and say beyond 2806?
No. You could. There's a bunch of different ways to word this and I'll accept it. Just all have to reference whatever the claim was. Now real quick, sorry. Was my finger in the way? Why does this make sense? The null thinks it's at most 2806. So the null thinks it should be in here. We got up here, so of course I can reject of course I can support this. I got so far above where I should have been if this was right, then it's more likely he's wrong than he's right. So I support what this guy says, because I made it so far away from where I should have been to support him, or to fail to reject him, that I actually can support this guy. Ugh. So one thing I want to be careful about is I never support the null. You cannot support the null, because a sample can never prove equals, ever. If I took a sample right now and got 27 years for an average age, does that mean anything about the population mean being 27? No. That's not proof, that it's not evidence that it's 27. It's just the sample mean. But I can find evidence against the sample mean, the population mean being 80 years old. Average age growth response, 80. Okay, well let me go take a sample and show you're an idiot. Okay, real quick. Right, so then my sample mean will be so far away from 80, that's evidence that that claim is wrong. Are you guys? So this idea of far away is what it's all about. And that's why I made a big deal out of z-scores being how we measure distance. So I'm measuring distance in z, or its equivalent, t. That's how I measure distance. So I measure what's far enough away. I measure how far we got. So I think I just said something backwards, but that's okay, Jeff. We did not find evidence, so we didn't make it up in here. We didn't quite make it there. So I couldn't say he was wrong. Okay.
Can we find type 1 error?
Yes, okay, wait. It's already roughly with me on this. Again, it's all about practice. We got 2 more problems I want to do.
Can you put that one?
Check, yes.
About p-value.
What did I say about p-value with t-scores? I'm not going to make you do it because you don't have enough information from your chart.
I bet you could just find the area of the z-score you found.
It's not a z-score,
Oh, it's t-score.
t-score. And there's not enough information on here.
Also p-value.
For any given degree of freedom, do I know a lot?
No.
That's one single row of 5 numbers. I don't know enough.
So it's only for z-scores.
Z-scores, because z-scores, I got a stupid amount of stuff I know for z-scores. I don't know if you guys are... Technology could tell me the p-value, and I don't care. Because technology doesn't really help us learn anything. Well, that's not true, but not for this. Not if it was doing it for us. Okay. So, what we need to talk about now is, for example, there's an election coming up. I know I've talked to you about it before. I'm not going to talk about it too much. I'm not going to state any stances I have or any bullshit like that, because who cares? But there's a lot of stuff about percentages, yes? 42% are going to vote for this person. 48% are going to vote for this other person, right? So that's being thrown around. So then the claim could be, I claim that the percentage are going to vote for this person is going to be more than the percentage. So I need to be able to test claims about percentages. We haven't done that yet. So here's a couple things that have to change before we're able to do this. Chumbawamba. Someday I'll remember to bring paper. That's all my keys. Okay, let's see. Do I have any paper? No. Thank you. Is that for me? Thank you. Okay. Wow, I've never been so constrained. Okay. So, here's what's going to happen. We have a z-score formula for means. So here's the idea. It seems to make sense. If I had like a claim about a percentage and then we took a sample percentage, yes? Remember the hatted one is the sample percentage? What should go on the top of its z-score formula is our data minus the population. Yes, that makes sense. So it's sort of like our data minus the middle, minus whatever the population is, just to see how far apart those are. Now on the bottom should go the equivalent of that guy. What the shit is that? So let me see. I'm going to take a little side. So we're not done with this formula. I got to figure out what goes in the bottom, yes? This is my quick, rough, dirty derivation of this formula, okay? Somebody remind me, what's the formula? For some reason, I'm going to do a confidence interval. What's the formula for the confidence interval? What goes here? Anybody remember?
No. R over square root of n.
Sigma over square root of n, yes? So isn't this sigma x bar?
Yeah.
Okay. What goes there in, get out of there, in a percentage one?
It's a p hat q hat over.
Overhead.
11. So isn't this the equivalent of this for percentages? See that? Because again, what is the z-score? It's the number of standard deviations away. Oh, so the number of so this must be standard deviation. That's what that is. How do I know that? Because it's next to the z-score. What goes next to the z-score is the standard deviation size. Because z-score is the number of standard deviations. So I can just steal this. Now here's what's going to be neat. You ready? I'm going to steal this. Along their way, they're going to lose some clothing. Very strange phrasing. I don't care. Phrasing.
Does it matter that the hats aren't there? Because you're not going to know PMQ for the entire population.
Or the p-hats are there.
So, real quick, can somebody remind me why, for the z-score formula, does the claim mean go here? Doesn't the claim mean always go there? Doesn't the number from the claim always go there? Because the idea of hypothesis test is we're going to assume this number really is the mean. Yes? So we assume we know mu. In a hypothesis test for percentages, we're going to have stuff like p, blah, 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 p, blah, blah. So we're going to assume that we know p. So if I know p, I'm not going to use frickin' p hat because, okay, what's p hat? Somebody tell me. Why has it got a hat on it? What's p hat? Sample percentage. The percentage of successes in a sample, correct? Isn't that so like S? What's S? Sample standard deviation. So when would I not use S if I had it?
If you know.
If I also know sigma, I would never frickin' use S. Sorry, S, but you're shit. But you're, no, it's not shit. But the poor little dude is an estimate for sigma. So if I know sigma, I'm going to use freaking estimate for sigma when I got sigma, yes? So if I'm assuming I know P, I'm never going to frickin' use P hat, because P hat's an estimate for P. So hypothesis tests, we're always assuming that the number in our claim is true. We're always assuming it's the mean, or in this case, we assume it's the real percentage. Why did I have to use those for a confidence interval? For a confidence interval, I don't have a clue what P is. We're trying to build an interval to figure out what P might be. I don't have a clue, so I had to use the hatted ones, right? I had to use P hat, Q hat, because I didn't know what the shit P was. Hypothesis test, I'm assuming I know what P is, so I can use it. I'm not going to use the hatted one.
Does that mean in this formula, you know what P is for the population?
Yes.
And then from there you derive Q by subtracting P from 1.
Yeah, no matter what clothing they're wearing, P and Q make one. Yes. I like it.
Is there a time when in that formula P hat and P will be different?
Oh, hell yeah, they gotta be. Well, they don't gotta be, but almost definitely. There's a percentage of gross fund students right now who smoke, correct? If I took a sample and got a percentage from the sample, will it equal the percentage of all gross fund students? I would put all the money in the bank, which is not much, but it's enough, on them being not equal, because it's a sample. It's almost definitely not going to be the same thing, and I would probably lose because I'm not going to be like equal. All right. I can tell you're all very excited about this. This is an idea. I want you to understand the idea. It doesn't affect the nuts and bolts. You could do the nuts and bolts without fully understanding a concept. This is true, but I always want you to understand the concept because then everything makes a little more sense. But let's try a problem together. I probably should give you a copy of this. Sorry. Huh? Sure. No, this is a practice test and this is a worksheet on hypothesis. Yeah, so hypothesis tests are just hypothesis tests. Practice is everything. Yeah.
If the money is ever an issue, you can just get a side job working for BAE, Lockheed, McDonnell Douglas.
I like to joke.
They're trying to
The
develop.
teachers don't make the most money in the world, but I'm fine. actually hoping to.
Actually, you gotta become tenured, then they can't fire you. Then you can
Oh, yeah?
curse around and have fun with us.
Takes 4 years to get tenure at
Really?
community college, yeah.
That's it.
I
I love
thought it
how
was
people
10.
assume it's 10 because
Yeah,
it sounds
10
like 10 years, but it's
years.
tenure. It's its own word.
I wonder if the standard is higher at like UCSD and SDSU, 1 to 4 years.
No.
Oh.
In fact, I remember I worked at university and one of my professors got tenure while I was there and I was invited to his party and they had a chair in the front and on it said DW and it stood for Deadwood. Because once you got tenure, you basically could just do nothing.
Congrats on joining the union. You're
Thankfully,
not fired.
most of them did something and only a few of them didn't do shit, but you know, you just go away.
That's funny.
Okay, read through this real quick. Am I still recording?
Yes.
What is this?
All right, guys. Percentage questions always have less stuff they give us because they don't have to give us as much stuff. Can somebody just tell me in English what the claim is? It's very direct.
Percentage is less than
Okay, so it's at most 55%. So the percentage of an unfavorable view of the police are at most 55%. So good. At most, in Mathish is less than or equal to. And I understand our brain sees the word most and we think bigger, but at most means up to. So where does that go? I'll tell you where it goes. No, stop. And again, make this ha, because I should update these, but I always forget to. Another book used to call it the highs, the hoes and the highs. So what goes in next to the ha then?
percentage is greater.
Greater. Is everybody really cool with why the hell we just did what we did? So you write the claim down. If it's got an equal sign, it goes next to the null. If it doesn't, it goes next to the ha, and whatever's blank is the opposite of what you wrote down. If neither of your statements have an equal sign, you did the opposite wrong, right? The opposite of something that doesn't have an equal sign has to have an equal sign. Is this a 1 or a 2-tail test? Good, 1 tail, because it's got a direction to it. It's got a directional word, at most, and it's got a greater than, so I know the tail is going to be up here. Yes?
So if it's a 2-tail test, that's always gonna be like equal.
Not equal to, yeah. If the claim is, then the opposite is not equal to. That's going to be 2 tails. Of course, if the claim was, we feel it's changed, that's directly not equal to, right? Yeah. So if you're having trouble figuring out if the claim is greater than whatever, it almost definitely is equal or not equal to, because you lose the word is, and you don't quite pick up on the word different or changed, right? Directional words are very in your face. Increase, decrease, at most, at least, yes.
So if it says, we believe it has not changed, that's not equal to.
We believe it has not changed is equal to. If it hasn't changed, that means it stayed the same. Yes. Okay. So 1 tail test. I know what my ha is. I know what my p number is now, right? All right, you guys get as far as you, well, let's see. Well, actually, let's do this together. I'll make you do the other side. Let's see if anybody's really been paying attention. I've got percentages. What do I check? What?
NP and Q.
Oh, NP, cat.
NP, NQ, no hacks. What's N? 996. What's P?
55.
Good. N is 996. What's Q? 45. Good. There you go. Whatever the shit that is. Let's see. That would be 498, 49.8, 47.8, 547.8.
Yeah.
Is that right? Yes.
Yes.
And this will be 448.2.
Yes.
Good, Jeff. All right, sorry. That's my one skill. It's the one skill I got. So everybody with me? You guys gotta be real careful. Means, either it says it's normal or n's greater than 30. Percentages, NP and Q. Gotta be at least 5.
NP hat and NQ hat.
That was when we had confidence intervals and we didn't know P, so we had to use the hatted one. Now I know P. P is 0.55.
Well, you also know P hat.
So what? Just like knowing sigma and S. I'm never gonna use S if I know sigma. Okay.
I was gonna say, we do know p hat, but there's no point in using it because we're given.
Yeah, we haven't even calculated yet. Well, I'm not gonna calculate P hat ever until I get to step D. Yes?
What is S? Like, what is that supposed to be?
Oh, I'm sorry. 5.
Okay.
I'll translate from Jeffish to, sorry.
I gotta publish a dictionary.
The number 5
Jeffish to English.
is one of my many nemesis. Okay? It's like the plural nemesis. Nemesis is, yeah. It's like banana, B-A-N-A-N-A-N-A-N-A. Okay. Is everybody with me? So what are we talking about? What am I allowed to use now? Is it normal enough? Yes. So what can I use? Z-scores. I should have said what can I use, but I didn't. Too bad for me. Now, real quick. If either one of these was less than 5,
You can't do anything.
I can't do shit. T-scores don't work with percentages. Poor little
Or
dudes.
T-scores.
Nope. So the beautiful thing about percentage problem is either Z or it's nothing.
Okay.
Which is again why I did section 8.3 before I did section 8.2, because 8.2 introduces T-scores, and I don't need T-scores for section 8.3. Yeah? Okay. Alright. Level significance 0.005. That's a one-tailed test. I can use Z-scores. So what is that Z-score going to be?
2.476.
Yes. So if you look up on the T-score chart, just to make sure everybody's with me. T-score chart, 0.005, one tail. Go all the way to the bottom, 2.576.
Wait, I just thought we can't use t-scores.
Totally, we don't have to use T-scores, so of course we go all the way to the bottom so we get a Z-score.
Oh, you looked it up on the z-score chart, okay.
T-score chart, this is the T-score chart.
What?
This is the T-score chart. What lives at the bottom? Oh, what lives at the bottom of the T-score chart? Z-scores live down there, yes. Why the hell, I love you guys right now, I love you. Why the hell are there Z-scores on the T-score chart, Jeff?
We are big enough.
Because when the sample gets really big, I don't need my ass covered. When the sample gets really, really big, I feel really good that S is the same as sigma. So T-score, I don't need you anymore, it's just Z-scores then. Yes?
But you told us that we were gonna look on the Z-squared chart. I thought it was negative, oh my gosh, negative 2.5, whatever's on the bottom right here of the Z-squared chart.
Oh. Alright. Where are you looking?
No,
At the very
confidence,
bottom.
confidence.
Oh, here. So, okay, so several things. I can use the Z-score chart, I can. I just won't, unless I give you an alpha that's not on the T-score chart. So, if I want, now real quick, help me out. Where's alpha in this picture? Where's alpha in this picture?
On the right, shaded.
It's the shaded piece, yes? If I want to use the Z-score chart, don't I have to look up this area, because it only understands areas below.
Yep, the area.
So do I have to look up 0.995?
I flipped it to the other side and looked up.
So you get this here, yes?
Yeah.
Which is an estimate because it was directly between 2. So the estimate here was right between 257 and 258. But if you're a little more precise, you actually get 2576. Now if you use the Z-score chart and you get 2575, I'm gonna work, that's fine, that's beautiful. Because it came from a chart I gave you, how could I be upset? Yes? Are you with me? But you don't have to use the Z-score chart. If the alpha I have is one of these, I can always go all the way down. So if I stop, I get a T-score. If I go all the way to the bottom, I get a Z-score. That kicks so much ass because it's set up perfectly for a hypothesis test. One tail, two tail, yes. But if you want to do it that way, perfectly fine. It just could get a little bit harder, but we've done that kind of stuff before. So it'll work, yeah, okay. So if you don't have 2576 and I do, who cares? I'll take 2575, that's perfect. Okay. So if Z star is what?
Great.
Greater than 2576, what will we do?
Reject the no.
Reject the no.
Support them.
Support the high. I like it. So it sounds like I just said two things, I didn't. These are both the same thing. If I say this guy's wrong, I'm automatically, implicitly saying this guy's right. I know. Yes. Oh, sorry. That was slide. So I gave us the z-score formula we sorted derived a minute ago. Can you guys get p hat? What am I going to divide to get p hat? Where's my sample?
594.
Yeah, 594 out of 996, yeah, so that's what I'm doing here. There's 996 total. Jeff, you can do it. 594 successes, so 594 divided by 996 is like 0.596.
Yeah.
Is it?
Yeah.
Neato. I just pulled that out of my ass.
Do you want
Can
that
we
to
round
be?
that up to 60 or no?
So again, sorry.
Can we round that up to 0.6 or?
No, don't.
Okay.
P hat is always 3 places at least. So if in doubt, whatever the hell you're looking at, round it to 4 places and you're covered, yeah? You with me? Percentages, 4 places. Z-scores, 2 places. P hat, 3 places. Standard deviation, 3, just make everything 4 places, you're covered. Yes? Okay. Yes?
We're not there yet, but once we know our z-star, would we then actually look up that corresponding z-star values area on the chart, and that'll give us p-values as a one-tailed test?
Yes. Okay, let's do this. So what's P hat?
Oh, sorry, 0.596.
What's P?
0.55.
Yes, it's always the number from the claim, right? 0.55. We're assuming that's the real middle. Square root. P, what's Q again?
0.45.
4.5 divided by N.
996.
So here's where you gotta be really careful about plugging this in your calculator. Let's see if we all get the same answer. Oh, I don't even have a calculator. There we go. Let's see. Can you do it in your head, Jeff? No. In my head. Let's see. Ooh. I get like 3 in my head for this problem.
We're close. 2.918.
Yeah, 2.92.
Yes.
So all the p-values, so first off, we already know the answer. Right? Did we make it far enough?
Yes.
Yes. The p-value right now, until I say what I'm gonna say about it, doesn't make any sense because it's just like one extra little step. The p-value in this case, it's a one-tailed test. So if you just look up, now be careful, it's the area in the tail that our z-score makes. So it's not gonna be 0.9 something, that makes no sense. Look how tiny that tail is, tiny. So when I look up 2.92, don't I have to do 1 minus that to get the other side? Yes? Does that sound familiar? So look up 2.92. What do you guys see?
0.9.
Yeah, 9982. But that's the area in the body. How much area is in the tail up here?
0018.
Yeah, what was it again? I forgot already.
0018.
0018? Now here's the trick. The smaller this is, do you agree with me that that's more significant? That's stronger and stronger evidence
Yeah.
to reject the null. In the real world, there are no alphas. In the real world, there are no level of significance. It just doesn't exist. What's reported are p-values, and then each person that reads it can go, that's significant to me, or somebody else can go, that's not good enough for me. Because it's got to come down to our own interpretation of what the results say. So if somebody got a p-value of 0.04, it's pretty good. But if their own alpha is 0.01, it's not good enough. It's not good enough. It's not good enough evidence. Bless you. I don't know if you guys are really with me. In this class, we have to be told an alpha because whatever field you're going into, you're going to develop your own alpha based on your own experiences. So when you read a journal article and it got p-values, you're going to go, that's good. That's not good enough for me. It's not good enough evidence. That's good enough evidence based on your own frickin' expectations. Right? I don't know if you guys are...
Kind of like the fire movie.
Sort of, yes. Of course, in that case, there's a little bit of insurance company greed.
Yeah, that's what they make it so hard.
Yes.
Sorry, what's the right way to look up that, using that Z-star p-value on the chart? 'Cause you're
So you look up 2.92. And when you do that, you're going to get the area
of the body.
here, and you got to do 1 minus the area in the tail. Yeah. Reject. So, conclusion time. So what did we do? Did we make it? Did we make it?
Yeah.
Yes. So we reject the null, support the how. What was the claim? Which one was the claim?
That we are less than 8.
So the ho was the claim, right? The null? So I'm going to use this language. So how do I write that conclusion then? We have a headache. No, we have found. Yeah, we made it. We have found sufficient evidence too. Reject the claim that. Plagiarize. At most, 55% of Chicago residents have an unfavorable view of their local police. Just plagiarize, right? That at most, 55% of who's from Chicago? Anybody? Is it Chicagoans?
No, because we made it here.
Huh?
It's a bad joke.
Bad joke. That's true.
It's true.
Chicago is. That was New York. Yeah, to make it. All right. At most, 55% of Chicagoans have an unfavorable view of their local good Lord police. Okay. That's pretty good English for me. Not the best. We have found sufficient evidence to reject the claim that at most 55% of Chicagoans have an unfavorable view of the local police. So we found evidence really that more than that.
Jump view.
Huh?
You didn't write view.
Oh, I didn't have unfavorable. They just have an unfavorable. That's all.
Where's Chicago?
I don't know how you have an adjective, but you just do. Or a
The
adverb.
chief of police was optimistic.
Unfavorable?
He's like, at most, more than half of you don't like us. And the data is like, it's more than that.
All right. You guys do this one. And while you're doing that one, I'm going to find a real life example on the interwebs to show you. On the Googles. Go to the Googles. Let's see. Interesting. No. Oh, okay, that'll be good. Holy shit. Come on. No.
This is gonna have to be all P hat, isn't it?
Say again?
This is gonna have to be a P hat problem, I think. Cause I don't see a definitive population percentage.
No, you never get a definitive population percentage. We assume the number from the claim is the population percentage. Holy. Oh. Oh gosh. No, let's see what this one says. No. Damn it. Okay, that's not possible. Oh, okay. There you go. Okay. Alright, let me catch up to you guys here. Oh, I didn't even pause the recording, so that's gonna be a really exciting part of it. Yeah. So help me out. What's the claim that's being made?
That percentage is different, so not equal to 84.5.
Good, so the claim is the proportion of students is different from this. So which one is that gonna be?
Ha.
Yeah, the hot. So what's the hope?
That it is
Equal to 84.
Yeah, so the opposite of not equal to is equal to. That's crazy. How many tail tests?
2.
So I really should, I think on a test or something I say, can we use z-scores? Why? So, can we use z-scores? Well, is it normal enough?
Yes.
Yeah, because what's n?
Sample size 322.
322, and p we take from the claim. So q is going to be the opposite of that. Somebody with me? Is that all right? So then, whatever the hell that is,
272.9, 49.
blah blah blah.
49.
49, blah blah blah. And those are at least 5. Check. So what does that mean?
Z-score.
Z-scores. And again, if either one of them are less than 5, can't do anything. Now, in reality, I'm never going to give you a problem like that because that would be so evil. Because somebody could do all this work they didn't need to, waste time, and I'm up here going, no, I'm just not that evil. 10 years ago I said, check in with me 10 years from now. I guess I'm still not that evil. Okay. So,
You're
you
never
pretty
gonna
much know going in it's going to work. You just got to show me, right?
So you're never going to do a negative karma playthrough.
Not this time around. Maybe next time. This is some kind of Roy game I'm playing right now. What's alpha? What did I say it was?
0.10.
0.10. It's a 2-tail test. It's going to be an easy-ass test.
Opposite of 90%.
It's a big old chunk, right? 10% chance to get something that'll
equals-
be evidence against this.
1.645.
Yeah, so again, if I look at my t-square chart, 2-tail, 0.10, go all the way to the bottom for z-score, 1.645. And just again, in case anybody, I'm always trying to guess at what questions people might have. There are no negatives on this chart at all. We're the ones that have to put the negative on. So a 1-tail that's down here or a 2-tail test, they're going to have a negative. At least a part of it's going to be negative, right? So if z star is
Greater than 1.6.
greater than this positive one or less than that negative one, we always do the same thing. That's why we call it the rejection region. Reject the ho, support the ha. So one thing to notice,
Wait, what do we reject? What is it?
if I get way out there,
Oh, yeah,
the null is the one that thinks it's in here.
we're not equal. Yeah.
So if I get way out there, that's evidence against the one that thinks it should show up in here. Yeah. What was I about to say?
But wait, the claim is that it is different.
Claim doesn't matter or shit. So the claim gets us started, and the minute I get started, I forget about it. A test is designed to find evidence in favor of ha against ho. That's how it always is. So I don't care. The test doesn't give a shit what our claim is. What are we kind of hoping for? If we really feel good about that claim, we're like, I think that claim is right. I'm kind of hoping that we reject the null, yes? Because that would be evidence for my claim. If my claim was it was equal to, then I'm sort of like, ooh, let's see if it's equal to. So I'm sort of hoping for this. But again, a scientist, if they are proven wrong, there's no happier day. You got to understand, because then they're like, oh, I don't even know what it could be. Holy shit. And then they have all these avenues that just opened. It's kind of boring. If, yeah, I got exactly what I thought I was going to get. Okay. Sorry. It's just really funny to me that there's a lot of people that believe scientists are like, anyway, COVID was an exciting time for statisticians. Just the misunderstanding of everything. But you're all better than that. You're all here.
Oh, you must have loved it when you found out what the fatality rate for it was and the reaction of world governments to it.
Well, it's always interesting to me when it turned out to have, at first it had almost a 2% and then it was like a 1% death rate.
Which
People like 1%, 1% of 340 million people
Well,
is 3 million people.
It kept
right?
going lower and lower until it was lower than like the seasonal flu, swine
True.
flu. Like,
But in the early going, that's because of the vaccine for the most part. Anyway, sorry. So I got the vaccine, I didn't become magnetic, I got no superpowers. I was really bummed. It's like, whatever. Sorry. So we set up what far enough away is. And this is definitely a smaller number than we're used to because my alpha's so big. It's not a very significant test if we pass it. These two steps really aren't necessary. You can pretty much see what p hat's going to be. What out of what?
the sample positive result.
Yeah, 282 out of
Sample size.
322, right? 282 out of 322.
1875.
Who is it?
876.
1875. Said not to round up.
Wait, what?
No, you have to round.
Oh.
Period. Yeah. Yeah. Don't
Why
just
wouldn't we round?
never truncate. Round.
So
0.87,
6 if you're doing
Six.
3 decimal places. Do you want 3 decimal places normally for this?
at least 3 for p hat always. By the way, just stick with me. This is the last thing we're doing, okay? It's warm in here. I'm done. We'll talk about types of error next time, okay?
Yay.
Okay. Just want you guys with me for the last bit of this problem. Okay. So how does this get set up? What's our p hat again?
0.876.
Yeah, we just did it. 876 minus what?
0.845.
Yeah, the number from the claim is what we're assuming to be true. Chalice from the palace holds root, which is true. Divided by the square root. Now here's where another mistake can be made.
I screwed this up. I put p hat, q hat.
Yeah, make sure it's the unhatted ones. So you gotta put 0.845, doesn't have a hat, that's P. And then times 0.155, that's Q. Don't use the hats. Divided by 322. Don't do that in your head, Jen. You can't do that in your head, stop it. No. Hopefully somebody would tell me if they're not getting the same answers. Because you gotta be careful how you put this in the calculator. Tell the top's gotta be in parentheses. Because the calculator doesn't have eyeballs. Divided by, don't close this parenthesis until you're at the end. Unless you have the newer, I don't know why I've got mine set to be like this, but if you have the one where the square root grows, it's nice. Make sure you don't come out of the square root.
I think
Yes?
the smart way is just do the bottom first. Just do the whole bottom, then square root it, and then or store it as x, then you can.
Sure, as long as you don't round.
Yeah.
I'd rather just throw it all in there so I let the calculator worry about every part of it.
Oh, I do the top first.
Yeah, whatever works. Just don't round.
How many
So we
decimal
should-
places did you want for Z stars? 2, right?
You tell me.
Because we're gonna look up the chart. So 1.54.
Yes. Did we succeed? This EasyS test,
Yes.
did we succeed? Did we make it far enough away?
No,
No.
Nope.
we have not.
Can you take a minute to figure out the p-value? When you look at 154, you should get, what do you get, 0.90? 9899? 98? Oh, Anita. Alright, let's see. So look up 1.54. Oh, yeah, okay, 9382. I don't know where I got my-
0.0618 times 2.
Yeah, so if you do 1 minus this, you do 1 minus this,
Or look at the negative.
or look at the next, sure, but if you do 1 minus this,
1 minute.
where'd it go? I keep losing.
0.0618.
0.0618. Yes? And then if you double that, why am I gonna double that? Because it's 2 tails. So it should get 0.1236. Which, now, I know you're all relatively new to this, But when I see a p-value like this, I'm like, oh, that's not shit, that's crap. P-value of 0.1236 means there's a 12% chance that what we saw was just normal random variation of a sample.
Okay.
That's way too big of a
P-value is margin
chance.
of error?
P-value is roughly the probability that we would have gotten our sample where we did if the mean really was, or if the middle really was what this thinks it is. Okay.
Do we,
So the bigger the p-value is, the less evidence that is to reject the null. So that's kind of why it makes sense. What did we do here? Did we make it? No. So we failed.
do we reject Ha and support Ho?
Never reject Ha.
What?
We failed to reject the Ho.
We failed to support.
Failed to support the Ha. So you either reject or fail to reject the Ho. You either support or fail to support the Ha.
I'm not gonna remember.
Kind of the same thing as you either say somebody is not guilty or guilty. You never say they're
That
innocent.
part's easy to remember, but what you just said, I'm gonna screw.
If I support the Ho, that's like saying somebody's innocent,
So if it,
and we never would do that. We just did not find enough evidence to show they're guilty, so we say at most they're not guilty, which is not the same thing as innocent. Do you guys understand that? This is a huge thing to understand about. Because we're humans, we're not infallible. We can make mistakes. So we can't say somebody's innocent, because that means we've proven they're innocent. We just haven't found enough evidence to say they're guilty. So we say they're not guilty. All right, enough of that. Sorry. Yes?
Jumping back a bit, p-value, how'd you grab that again? It's 1 minus the.
Yeah, so look at 1.54. You get 0.0618. And then if you double that, you get 1236. I doubled it because it's a two-tailed test.
Okay.
So the area of the tail of 154 is 0.0618. And then if you double it, you get 1236. So the conclusion. Which one was my claim?
so, or the,
Yeah, the Ha was the claim, so I'm going to use this language. So we have not found. If you thought I couldn't write before, now you really. Sufficient evidence to support the claim that, oh my goodness, that's a lot of words. Passing, good Lord. Blah, 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 blah.
what did you
So
pass?
the claim is the proportion of students is different, that the percentage of students who feel passing, okay, blah, blah, blah. You can just copy the words. Yes, just copy. I already wrote them once. You can write them yourselves. So at that step, you just say, rewrite the claim is. I want to show you this real quick because I found it, and this will be it.
Wait, so I'm just trying to word this correctly. We have not found sufficient evidence that the proportion of students that strongly agree passing a full week stats summer course and retaining information is an impressive feat in comparison to the professor.
Yeah. So
Oh, it's different. It's different.
look here real quick. It almost doesn't matter what this is. Do you see here P less than 0.001? So as I'm reading this, that pretty much would be enough evidence for almost everybody. 0.001 is stupid small. That's really strong evidence. I don't know anybody who would say, that's not good enough. So you're never going to see an alpha. You're never going to see a z-score. You're going to see p-values. P-values are how other people make decisions as to what these people saw. Is it good enough evidence? So I had another one. It's just another p-value, so it doesn't matter. This was about people think old age starts later. This one was about something from NASA.
So they only give you p-values?
Yeah, you only see p-values. You'll never see alpha. You'll never see that. You'll see
So there you
p-values.
just have to memorize that a small p-value means it's not called margin of error, but it's like there's a really low chance that the sampling was screwed
Yeah,
up.
the smaller the p-value is, the lower the chance is that you just happen to get a sample that was really far away from the true mean. It's more likely that it's evidence that the mean is not the same.
Do you have extra of these?
What are those?
Like the hand worksheets you passed out?
Oh, both of them? Both of them?
Yeah.
And I mean, logically, a small p-value.
How many extra? One extra?
Both? Just both?
Sure, one extra both?
Yes, please.
Okay.
Thank you.
killing me. I gotta remember I could throw some handouts up in Canvas.
Okay.
Yeah.
I'll email